Hi, have you ever bought something on the internet? Well, then you must have given your credit card details and you want those to be safe. Or you've heard of cryptocurrencies like Bitcoin, blockchain perhaps, or applications that cipher your messages like WhatsApp. Then you are relying on a mathematical problem that has not yet been solved. And if you were to solve this problem, then not only would you become instantly a millionaire, but also the internet as we know it today would collapse. In order to understand what this problem is, I have designed a little game for you. I've called it the RSA Cryptocracker. Player 1 chooses a composite number at first. Then it's player 2's turn. He chooses any number except not 1. Then player 1 plays and can choose any number here, and player 2 will place any number here. The numbers are being multiplied, and if you can make the equation true, then you win. Okay, Cyril, ready to play?
Yes.
Great. So, you can choose if you're going to be first or second. What are you choosing?
Second.
Second. Okay, and my number is 10.
Okay.
I'll write that here. I'll put it here. Okay, what will you play? Place that here. Okay, 3. So I'm doing 10 times 3.
And 15.
So I'm doing 10 times 3.
And 15.
All right, 10 times 3 is 30, and 2 times 15 is 30 as well. Well done, congratulations, you've won, and you can open the Cryptocracker and get some chocolates. Okay, so Cyril, are you staying second, or do you think it's better to go first? You staying second?
I stay second.
Okay, perfect. So I'll start with 35. All right, so here I've played 35 times 2. Cyril, you played 8. What are you playing now?
I've lost.
Ah, you've lost. Bad luck. Never mind. I'm putting a cross here. You didn't win that one. No chocolates this time. Okay. Are you staying with your strategy of starting second?
No, I take the first.
Okay. Cyril, you've played a 12 here to begin with. I played 3. Now what's going to happen? Are you going to win this, do you think?
I think not.
I can now play 16 and beat you. Right, Cyril, so you changed strategy to second again.
Yes.
And we've just played this. I played 24, you played 3. I multiplied by 10. And then you multiplied by 80. And you've won because that makes 240 on each side. Well done. Another chocolate. So you've played 3 times against me, and every time you've won, you've stuck to your strategy of starting second. I've tried all kinds of things and couldn't win. I've even tried this number here, but he's played 2, and I think I've lost because 1,234 is divisible by 2, so I can't think of anything I can put here, and I'm giving up on that one, and you've won another chocolate. So, do you think it's always better to start second in this game?
Yes.
Right, I need to try something a bit harder here for you now, Cyril. Let's play this number here. And you played very cleverly 13, and so I played anything like 2, and you managed to beat me with 13 times 34. I have to think a bit harder now this time. I'll play this number. And actually, you can have your calculator, but I think I can go and get a cup of coffee here.
Yes.
7 times 47. So it's the product of 2 prime numbers, which are pretty big, and they were well hidden, and you had trouble here to find another number. I'll give you another one just to think about. It's this one.
Ooh.
Now, good luck with that one. I think I'll give it away for you. This one is 547 times 557. Both are prime numbers. I can guarantee you that these two are composite numbers, but here's the two prime factors which give up 304,679. And that you'd have a lot of trouble to factorize that. Like starting second was a good idea to you for a while, but actually it turns out that's not the best strategy. It's better to be first so long as you know the right number to choose. In theory, it's possible to beat any number here, but in practice it turns out to be incredibly difficult if you choose right. This is a fundamental problem in mathematics that has not been solved yet. It's an open problem. It's very easy for a calculator or a computer to multiply two numbers, but it's very hard to factorize two numbers, especially if the number like this one is a composite number that is the product of two prime numbers that are more or less similar. And so I'll show you that here. It's very easy to do this, P times Q. It's very easy to calculate the answer to this one. But if I give you the answer, this number here, there is no known method to calculate back to the two prime factors that make up this number. And I could show you, for example, this number here. This is a monster number, really big one. And in fact, this number has never been factorized yet. This is a number that's been suggested by three mathematicians called Rivest, Shamir, and Edelman. And that's why this is called the RSA Cryptocracker. And it's called the RSA problem. It's very easy to multiply, but very difficult, or at least we don't know how to get back to the prime factors originally. If I knew one of the factors of this huge number here, then that's like having a secret. And I can use secrets to transfer information on the internet. It's like having a secret code. You could use that to transfer something like your credit card number. And if I'm invited to Science on Stage, not only will you get to try out this game, but of course I'll show you also how the secret is being used. It's because it's really, really difficult to find this number D here when you know E and M. And that's linked to this problem of factorizing that I'm showing with this game.